Alright, let's look at this question here. So this question, so we have y equals to ln, and this function is in ln. It's a function in the ln, right? So we can apply logarithmic law. So where this is x squared multiplied with ex, right? So there are two methods here. One is you 1 over this function and you're using product rule, right? So but for ln, if possible, we try to avoid product rule if its condition is okay. So for example, these cases, so I try to avoid. So okay, I write for you and you see that, right? So because this is multiply, so this is, you can ln of this function, ln a plus with ln e power x. So then we can further simplify, as this is x power of 2, we can rewrite to be 2 ln x. Alright, 2 ln x plus with, we simplify first, it will be very easy. So then we can bring down the x. This is a power, right? As you see that this is a power of e, so we can bring it down. So we have ln e. As you know that ln e is 1, right? Ln e is 1, so you have y equals to 2 ln x plus with x. You see that it's much more easier compared to this. It is so easy compared to this one. In terms of differentiate, I think you should simplify first. Alright, so now you have 2 ln x plus with x. So now you start differentiating. So dy dx. So 2 differentiate ln x, you know the formula will be 1 over x, right? And differentiating x, you will have 1. So your answer will be 2 over x plus 1. It's a lot easier. So now in this video, I'm going to talk about some tricky question, right? So that when you answer that type of question, you know what to do, all right? What to do. So, all right, let's move on for the next example. All right, let's look at this question. So there are two methods. One will be a complicated, where you apply the formula for differentiate ln. You can 1 over this whole thing, and you differentiate this one by using quotient rule. But for me, I will always tell you that if for ln, we try to apply the rule of logarithm here. As you see that this is a ln, it's a single function where inside there is a division, right? So we can, using the concept of ln means we're not differentiating yet. So we are actually simplifying first. So I can rewrite this thing. So you try to see what I'm doing. So I was doing minus. Why I can doing this? Because there is a divide here, a over b. So I can say ln a minus with ln b, right? So y equals to ln 2x power of 2 plus 1, right? 2x power of 2 plus 1. And you know that square root is 1 over 2, right? 1 over 2 minus with, this one you clearly say that is x power of 3. So you can bring down the 3 ln x here. We are not differentiating, okay? We are not differentiating yet. So y, and for this case, the 1 over 2, we can bring forward also 1 over 2 ln 2x squared plus 1, right? Minus with 3 ln x. Now we have simplified this one, considered as complicated, to a simplified form, all right? So I think we can start differentiating by using the formula for derivative of ln function here. So now I'm starting derive. So your dy dx will be differentiate. This is a constant, right? This is a constant. So I just 1 over 2. So differentiate the ln. This is your fx, right? So you have 1 over 2x, 2x squared plus 1, right? 2x squared plus 1. And 1 over the 2x squared, and differentiate this function here. You multiply and you're differentiating, you're getting 2x squared, you differentiate, you're getting 4x. And 1, you're getting 0, right? And minus with, so this will be bracket, this is for this part. So now minus 3, differentiate ln x, you know, is 1 over x. 1 over x, so it's 3 over x. So means that dy dx, right, dy dx is the same as 2, 2, 4. So you have 2x, right, 2x over with 2x plus 2x squared plus 1, 2x minus with 3 over x. And this will be your answer for this problem here. So it's a lot simpler compared to you using the quotient rule. Alright, so let's go for the third example. Alright, this will be the third example, and this is not a single ln function, right? You see that there is a product between this ln function and this is not inside there, right? It's x squared multiplied with ln 2x. So you try to refresh back what you have already learned, the rules of differentiation which is involved here is that the quadratic x squared multiplied with the ln 2x. So it's a product, right? Product. So we're going to using product rule. So you still remember product rule? So product rule will be y equals to uv. So as you find dy dx, it will be u v prime, right? You differentiate the v plus with v u prime. Okay, so now I'm going to write what is my u and what is my v, right? So in these cases here, this is your u. It's a quadratic function. It's a function multiplied with another logarithm function, so v. So you know that your u will be x to the power of 2 and this will be ln 2x, right? As simple as that. So okay, now I start differentiating this as I need the differentiate of this. So differentiate du dx is same as u prime. So differentiate x squared, you will have 2x. Right? Okay. So it means that this one we were using the rule of derivative of ln, right? So which will be ln fx here. So 1 over 2x. Differentiate 2x, you have 2. So you were getting v prime to be 1 over x. Now you have all the information. You have u, you have v prime, you have v, you have u prime. You can apply the formula, right? So this is a product rule, right? Applying product rule. So your dy dx will be equals to uv, your u v prime. So u v prime 1 over x plus, right? Plus with v. Your v is ln 2x. Ln 2x multiply with u prime, right? U prime, which is 2x. So, and this one x squared and x, you will have x. So you have x plus with 2x, x, right? Plus with 2x ln 2x. Alright, this will be your answer. Or you can actually factorize the x. So you have 1 plus with 2 ln 2x, right? So this will be the answer. So it means that this type of question we are applying product rule. Alright, let's see the next examples. Alright, let's look at this example. So there is a ln inside here, but there is doesn't matter here. So the problem here is we look at this type of function, so which is a division between a ln function and a quadratic function, right? So it's involving a rational function, so which is the division, right? So in these cases we're going to apply the quotient rule, as quotient rule is more suitable, right? So it means that on top here you will have your u and here you have your v, right? So quotient rule must be the most suitable form. So okay, let's revise quotient rule. So as you know that y equals to u over v, the short form, the formula for quotient rule will be you writing back the u, the v, and u prime minus with u v prime divided by v to the power of 2. So this is what we need to do. So we have v u prime minus u v prime. So over with v to the power of 2. So we're going to apply this formula. So of course I have to list out u, okay? u to be ln square root of x, ln square of x. So and your v to be x squared minus 1. Okay, identify your u, identify your v, and of course pick the correct rules of differentiation. So before you differentiate this thing, you have to know that you have some skill of ln where the square root is 1 over 2. You can bring forward, become 1 over 2 before you differentiating. So now you differentiating du dx. So become half. Differentiate ln, you have 1 over x. So means that your u prime, you are getting 1 over 2x, right? Your u prime is 1 over 2x. And how about for v prime? Differentiate dv dx. So differentiate x squared, you have 2x, negative 1. So this is your u, all the information that you needed. So now I applying the quotient rule. Okay, dy dx. The quotient rule formula will be vu prime. vu prime. So look at here, v, right? vu prime. So you have x squared minus 1, v u prime 1 over 2x, right? 1 over 2x. So minus with u, ln square root of x, u v prime, u v prime, so 2x. So everything you divided by v to the power of 2, x power of 2, x power of 2 minus 1 to the power of 2. Okay, now you have simplified, right? In this form here. So, okay, now it's the algebra. So that you want to solve the algebra here. So, okay, you have applied everything correctly. So the case now is you're going to deal with this algebra here, as this is over 1, this is over 2x, and this is over 1, right? So I think here I should multiply with 2x to make the denominator the same. So I having x squared minus 1 divided by 2x, this one, and minus, as I need 2x here, so I have 2x here, right? I have 2x here. Here you have 2 to 4x squared, right? 4x squared, 2 to x squared. So you have ln square root of x. So further, you divide everything by x to the power of 2 minus 1 to the power of 2, right? So I'm going to show you how to do this with this algebra here. Alright, let's see, right? Let's look at this. So since they already have the same denominator, right? Same denominator, so I can recombine them as x power of 2 minus 1, everything over with 2x minus with 4x to the power of 2, 4x power of 2, ln square root of x, right? So everything divide by x squared minus 1 to the power of 2. Right? As you have a divided by b and divided by c, usually in fraction, the knowledge of fraction, we will take b multiply with c, right? As a over b over c, so we will rewrite as, okay, for this I will rewrite as x to the power of 2, x power of 2 minus with 4x squared ln square of x, right? Minus 1 over with b, c, right? So become 2x, b multiplied with the c, x squared minus 1 to the power of 2. Now this will be a better, right? Consider better compared to this form. So you have to simplify until some step here. So, okay, let's look for another examples. Alright, now let's look at the final example of this video. All the example I given doesn't mean for you to really go and watch it before you solve it. So you have to solve it, you have to differentiate it, then you look at your mistake by viewing my video. That's a correct way of study. Alright, that is a correct way of study the video here. So this is a video lesson. I hope that you really try it. So, and of course, you look at this one, this is the product, right? It's a product between an exponential function and a ln function, right? So it's a ln. So, of course, what you can see here is a product form, right? So we will apply product rule. So, okay, so product rule, you have u, you have a v. So your u in this case will be e to the power of negative 2x. And v will be ln 1 minus 2x, right? V will be ln 1 minus 2x, e to the power of negative 2x. So now you differentiate, differentiating the u, alright, differentiating the u. So you were having, differentiating, you will have e to the power of negative 2x, right? E to the power of negative 2x, and you differentiate the negative 2 here. Do you still remember that differentiate exponent? You copy back the exponent and you differentiate the power and you have negative 2, right? This will be your u prime and your v prime. I revise both formula, right? Exponent, you copy back and you differentiate the power. For ln, you 1 over the function 1 minus 2x and you differentiate the function inside there. Multiply -2. So, okay, now I can apply this formula by using product rule. As you know that product rule will be the dy dx is uv prime vu prime, right? Uv prime. So your dy dx will be u e -2x u v prime. So v prime, you can taking from here, v prime will be -2 divided by 1 minus 2x, right? 1 minus 2x plus with u v prime v. Now it's your v. Ln, it's like taking turn for product rule. So ln 1 minus 2x and u prime, right? U prime. So will be -2 e -2x. You have applied everything correctly, right? So now, okay, I think if I will just factorize -2, right? Factorize -2 exponent, and here also you have -2 e to the power of -2x. So I can factorize -2 e to the power of -2x. Okay, I factor out this one, -2 e to the power of -2x. You factor out, as inside you still have 1 over 1 minus 2x, right? 1 over 1 minus 2x plus with ln 1 minus 2x. Alright, 1 minus 2x and 1 over 1 minus 2x. So I think this should be enough. Okay, I am already happy with my solution. Alright, okay, I hope you already understand all the basic rule. Basic rule, product rule, chain rule, power rule, everything I have already discussed, and many times I have already discussed about product rule and quotient rule. Hope you can see. Okay, in the coming video, I'm going to talk about trigonometric differentiation. Differentiation of trigonometric function. So it's even more interesting. Okay, see you.